Hey guys, so today you and I are going to talk about when to stop. So let's get into it. So the question in question was, Frederick, when you start thinking about solutions as layers of abstractions, how do you know when to stop? Well, it sort of the way that at least I think about it is that I know when I should stop abstracting, or I don't really think in terms of abstraction first per se, or rather I do think in abstraction first, but only when I understand it only started happening after I had trained myself to understand why I need the abstraction, if that makes sense. So, to give you an analogy that I think works fairly well, is like this. So if you have a need, which is the thing that I like to think that I always start with, I have a need of some sort. Now, in the real world, let's say that you have a need for food. Well, as a inexperienced food gatherer, you might think, all right, well, I should probably go out and hunt or farm the land or something like that, right? But then I, as someone who is a software developer, like someone who might have a higher understanding of food gathering, might say, well, yes, but you might have multiple people now farming and so forth. That's probably not going to be very sustainable over time. So maybe we need to establish some type of repository or somewhere where people can get easy access to food, as opposed to having to create their own farms or go out hunting, etc., etc. And so that means that I now need to create somewhere where, like, some type of service or some type of place people can go to get food. And this is my clunky way of saying that when you know that people need food and you want to make that as smooth as possible for them, it's better for you to, in terms of how you structure that solution, to say, all right, let's create a place to go for food, and then you can simply pick it up, as opposed to having to grow it yourself. And the same way I think about abstractions. In other words, I know, for an example, that in this food situation, that the bare minimum I would need in order to make this sort of thing happen would be to create basically a supermarket of some sort, where they can go and pick their food, they can get everything they want, and that becomes my abstraction. So we convert this to code. I know that let's say, for the sake of argument, that you have databases or some type of data sources or something that you need to access. I know that instead of having people write out the same query or create their own farm, if that makes sense, over and over and over and over, I know that their need is not to write like the queries or in my analogy, grow their food. Their need is to eat. That's what they need. And so I create an abstraction that allows me to take control over how they get that need fulfilled, because the interface, or the abstraction that I create, its purpose is to just provide the value of what it is that someone wants. It's the same thing you guys do when you use functions, for example. So an example would be if you work with arrays in, say, JavaScript. Like, I like to use JavaScript because most people are familiar with it. You have the map function, the filter function, the for each function, etc., etc. That is exactly the sort of thing I'm talking about, where someone sat down and realized that here you have an array, and I'm probably going to need to be able to find a way to filter out information, so let's create an abstraction for that specific purpose. And when you go, at least I've found that when you think about things from a need perspective, that is when you know that you have, then you know what level of abstraction you need to provide to the person. Because an example, if we take my food analogy again, the first iteration was, as I was saying, you had like markets, or you have supermarkets, etc., etc. So you see, if you look through history, people have refined the need of getting food to the point where now you have like apps that allow you to order food to just be delivered to your home. But we didn't start out that way. We started out with something more basic, and that iterative refinement of abstraction is the thing that I do. Because the problem is, and this is the thing that is always very dangerous, this is the number one problem that every single software developer have, and this is something where you are going to, like in the beginning, this is going to be a very fine line for you to tread. I have fallen into this pitfall myself, and you're probably going to do the same thing. And that is that you're going to over-abstract. Because when you start getting, it's almost a rewarding sensation when you understand how to create good abstractions, when you start to feel that sense of empowerment of going from just writing really shitty code to finding like, wow, I can make this much more convenient if I just add a function or a class or whatever you might be using, some type of abstraction, right? And then you start getting fancy. This is where, like, it's to make that analogy again to like the real world. This is when companies, make a solution that is overly complicated, where they've thought they were clever, but the customers are actually kind of unhappy because they have lost touch with what their need is. And that is the rule that I follow. I've tried to preach: keep it simple, stupid. Figure out what it is that people need, and give them exactly that. And then wait. Don't try to be smart before you see that there's more, there's a greater need. Because if you add more and more and more abstractions, you're actually going to complicate your code even further. And I've seen this happen. It happens all the time, guys. Like, I would say it's almost at least once a week or maybe once a month, depending on what we're working on and what type of people I'm dealing with, where I see people. I mean, I do it as well, guys. Yesterday I had to undo something that I had, like, which is this thing that you do, right? Oh, if I do this thing now, in the future we will be able to cover this case or so forth. You're basically writing code for an abstraction for a situation that doesn't exist. And that is it's a fine line. I don't think you ever fully get away from it. I mean, even master software developers who maintain the biggest projects in the world will, they openly admit that some things that they added into even the language standards was sort of a mistake. The classic one, the most famous one, is the null value, for example, where they basically, it was a mistake, as we call it, or like it's considered to have been, quote unquote, have been a mistake. And you're gonna fall in this pit over and over. But I've at least found that if you start by understanding what is the purpose of my abstraction, what is the need that I'm trying to provide here, and then have that with you, how can I fix that? What is the simplest abstraction that I can provide that but that still captures the need that the person or whoever's going to use this code or whatever I'm going to use it for, how do I make that happen? And it's with practice and training you get better and better at that stuff. So what I want you to take away from this is that the way that I know when to stop adding abstractions is when I know that my need has been covered, when I know that there is nothing more, like that there's nothing lacking. That's the key thing. There's nothing missing from the specific abstraction that I've created that I need right now. I don't try to add things that I don't very specifically need. It's only as much as I need, because, as I said, it's better for you to ship an abstraction that is just good enough for your situation to cover that need, and then find that you need to add to it, than it is to make an abstraction that is too much. When you start thinking in terms of, yeah, but if I do this further down the line, I'm going to be able to get these benefits and these benefits. As soon as you start thinking in the future with your abstraction, you're already in a danger zone. Like, that's where you should be very, very careful. And as with my little story where I had to undo something, sometimes you can be mature, you can be a responsible over-engineer like myself, where you don't really know which option to go with. Like in the specific scenario, I had 2 options to go with, and I wasn't 100% sure which one was going to be the good choice here. So I said, all right, let's go, because then I asked that question that I've had mentioned a few times as well, guys. If I know that the cost of undoing my mistake or my assumption here is very, very low, it will be it's not going to lock me in or anything like that, then I can make a guess. Then I can be a little bit more clever than I should have been. And then, because I know the transitioning will be very cheap. And so that's exactly what happened. I tried to be clever. Turns out that I wasn't very clever, because later down the line it turned out that this was not the best solution. And the cost of moving was like, it took me less than an hour to undo that mistake, and there was no problem. So I did an experiment. It didn't turn out so well, but at the very least I haven't like created a situation where it's now problematic for me to change my mind. And that's what I urge you to do as well, guys. Only go as far as you know that you need to go in order to cover the need with your abstraction, and then let the next iteration organically evolve, because it might turn out that you never have to update this thing ever again. An example that I like to give in the real world is the elevator. So we have more and more modern elevators, but the fundamental thing that an elevator does is the same thing it's always been doing. So it's an abstraction, if you will. Now I'm playing with words here, but it's an abstraction that is almost as ancient as civilization itself, and we've never really had to update it all that much, because it's a good abstraction and the need that we have is covered by that abstraction. So why make it more complicated than it has to be? Have a great day.